Hi everybody, this video is a summary of JavaScript intended for programmers. So I'm assuming that you already know a programming language and you just need kind of a quick start to learn JavaScript. In the notes associated with this video, I give other resources that may be helpful in learning the language. So let's just get started. Comments in JavaScript are just like comments in most other languages, where we have the double slash to be a single line comment and that slash star to be a multi-line comment. We'll see this in upcoming examples. Variables, instead of giving what type they are, like int or float or string, the two options are let and const. So we can say let weight equals 120 or const factor equals 33. And let me just give you some examples of those. So here I am at an editor, and let me just do some comments. So first, an example of let, and that syntax is let, and then the variable name. Variable names are much like variable names in any other language. If you want to know the specifics, I guess, look up online resources, but pretty much if you know another language, the variable names will be similar. Let x equals 5. And let me just print that. The print statement, when JavaScript was originally developed, there wasn't an option to print stuff to the screen, and that developed later. And the one we're going to use is just console log, that x. And we're going to be using it throughout this tutorial. So that'll just print that. The other option is const, and const is immutable, meaning the value can't change once you set it. So I'll just write immutable. And that example would be, so I can do y is a constant, and its value is 6. So let me just save that, and let's go to a terminal. And to run it, I'm just going to say node, and the file name, in my case, it was Scratch. And it prints 5 and 6. So not surprising. So let is mutable. Let me just add that to my comments here, meaning the value can change. So we can say let x equals 5, and then later we can say x equals x plus 2. So that's meaning mutable, so the value of x changes. Here, if I try to change y equals, let's just say it's equal to x now. Let me just save that, run that function, and you see I get that error, assignment to constant variable. So const, the value cannot change. Let me just comment this line out. This is just showing that x can change, right? So x initially was 5, and here I'm adding 2 to x. So that'll work. And so we get the answer 7 there. Let me just delete this. So the thing about const is that once it points to an object, it has to point to that same object, but the values within an object can change. So let me just kind of show you that example. And let me just call the variable name object. And let's say it's, I have some name entry here, and let's say that value is Anne, and let's call that good. And now here I can change something within that object. So I can say the age value of object is 20. And this will work even though I'm changing something within the object. This obj variable still is pointing to the same object. So let me just run that one. So we don't get an error here, we just get the correct value. So that's the difference between const and let. And we should always use let only when we can't use const. So your first thought should be, can I use const here? So it's only when we can't use const that we should consider using let. So here are the data types in JavaScript. So in JavaScript, we only have this idea of a number, which is a floating point. We don't have these distinctions between integers and floating points and different types of floating points. So just number. We have a string, which is exactly identical, pretty much like a string in any other programming language. We have a Boolean, which is true and false. We have the sense of an object, which I showed you just a second ago, which had different values within it, like a name and an age. We have two kind of undefined or let's just call them undefined objects, which are null and undefined, and we have an array. And let me just give you, we have other things as well, but those are the basic types. So let me just give you kind of an example of these. Go back here. And let's just call it data types. So I said we have a number, so I'll use const. Name, so let's do a string one. Let's just call it current. So let's create an object here, const obj equals okay, and finally the array version, const our array and it can contain things like num, name, current. And finally, let's do a print of all that stuff. All right, so let's see how that works. And here you see we printed 1, 2, 3, 32, and true, and then that object. So I think we've gotten kind of a quick rundown of what the different data types are. So let's look at control flow statements. And these are, again, similar to other programming languages. We have an if statement that looks pretty much no different than any other, than that in any other language. So let me show you that. And let's set a variable equal 12. If x modulo 2 is 0, then we know it's an even number, and I'll just print that. Okay, that looks good. Let me save that and run that. And it's an even number, not a surprise. So I set x to be 12 here, and then I say if x modulo 2 is 0, print even number, else print odd number. And you may see that when I hit save, the formatting of my JavaScript changes. That's because I have a Prettyfire plugin to my editor. I use Sublime Editor, and I think I use JS Prettyfire. I think I use JS Prettyfire. So that's why things change. All right. So that was if. The for loops are pretty similar to other for loops, or at least this type of for loop. And let's just take a look at that one. And the syntax is for let I equal 0, while I is smaller than 10. I plus plus. This is a pretty prototypical example of from other languages. I'm going to just log that I. Looks reasonable. And I print from 0 to 9. Again, not a surprise. Looks pretty similar to other languages. So with that, let's do the traditional Fizz Buzz. The claim is that 90-some% of the people who apply for programming jobs can't do this exercise. Hard to believe. Maybe it's just urban myth. So write a program that prints the numbers from 1 to 100, but for multiples of 3, print Fizz instead of the number, and for multiples of 5, print Buzz, and for numbers which are multiples of both 3 and 5, print Fizz Buzz. All right, that seems pretty easy. But exercises are use of the if statement and of the for loop. So we want to go from 1 to 100 here. So let me do that from 1 to less than or equal to 100. And let's see what we need. So if the number is divisible by I mod 15 equals 0. So it's divisible by 3 and 5. So we want, in this case, we want to print Fizz Buzz. All right, else if I mod 3 is 0, so it's divisible by 3. That's where we're printing Fizz. Now let's check if it's divisible by 5. Let me get the spelling right. Or, then we just print the number I. All right, I think that's good. So from I to 1 to 100, if it's divisible by 3 and 5, we print Fizz Buzz. If it's divisible by 3, we print Fizz. And now if it's divisible by 5, we print Buzz. Else, we just print the number. And there we have the results. Let's see if that works. Let's go away to the beginning and see if that works. I guess that starts there. So we have 1, 2, Fizz, 4, Buzz, Fizz, and so on. So that looks pretty good. So we've successfully done the program for Fizz Buzz. There's also this other type of loop, the for of loop, which is similar to loops in Python. So if you've worked with Python, you'll be familiar with this loop. And let's take a look at that. So we have some array or something we can iterate over, friends, and then we just, through each loop, we set a variable to each member in turn of that. So for the first part through this loop, friend will be associated with Anne. Second time through the loop, friend will be associated with Ben. Third time, Clara. And fourth time, Dan. So let's see how that works. Let me just get rid of this. All right, I put in some names. Let's call that good. And then the for statement is simply this, for so again, each time through the loop, this friend will be associated with a different element of that array. So first time friend is Lefty, next Buck, Nancy, and Lil. Let's just keep it simple and do that log. So it just simply prints each element in that list, one right after another. All right, let's try something a little bit different. Let's say I'm buying things. I don't know. Okay, so I'm calling them items. So let's say the cost of various items. And let me just change this here. So this was $5. This was $12.50. This was $27.67. This was just $32, let's say, and this was $100. All right, and I just want to know what the total amount is that I spent. So for cost, I don't know, of items. Okay, and I need to get some total variable. These are sort of pretty rudimentary examples, but just an example of how these for loops work. Okay, let's try it. So that costs, there was a little roundy error, but $177.17. Sweet. All right, let's see what else we need to know. While loops are pretty simple, just identical to other programming languages. Let me just give you an example of that. Let's just use this one here. And here's the condition. So while it's smaller than 10, I'll say console log. And here let's just, so we're going to increase the value of x each time. And let's call that good. It just prints the numbers from 0 to 9. Nothing that exciting. We also have a do-while loop, which looks like this. Again, many programming languages have this do-while. So do this. Oop, I think I have that in my. Let's just save that. And we get the same result in this case, but you see that we have both those options. Again, what do does that while doesn't is that we're guaranteed to go into the loop at least once. So asserts are very handy. They're in lots of languages and they're not used as much as I think people probably should use them. And assertions state facts about conditions. So like the values of variables, for example, that must be true. If that assertion is not true, then an exception will be thrown. So here's the template for assert. So we first load in the module that lets us use assert. Then we just have this assert.equal. So x, here we're asserting that x equals 15. If it doesn't, as I mentioned before, an exception is raised. Here I'm saying that assert is that x is between 1 and 10. So let me just show you those examples. All right, so x is 5. Okay, so now we can say we can assert that x equals 5 here. So this is a convoluted example, but later on in the course we'll be using assert quite a bit because we'll be getting some input in and we just want to do some sort of sanity check on that input, or we want to make sure that things, that the program that we wrote is producing the correct results. So again, if it doesn't equal 5, it would throw an exception. Let's just give that one a shot. That seems like a pretty easy one. And it ran and it didn't create a problem. Let's say now it has to equal 6. Obviously that's not true. And we get this assertion error. So you see it's a really helpful thing in the program to have these asserts. The other option I gave was that we are asserting that x is smaller or than 10. Let me just kind of put more parentheses in here because I like them. Give that a shot. So that works fine. And if x is 15, again, I get that assertion error. So that's assert. It's a very simple thing to understand, but it's extremely useful. And now another thing which is pretty similar to any other programming language you've used is these exceptions, which are try and catch and then throwing exceptions. So the syntax is similar to those of other programming languages. Let's just give that a shot. So for this one, let's read it in a file. So let me do that. Let's load in that module that understands about file systems. And let's load this file, because we know we have scratch.js. That's the one I've been always saving. And I'll read it as UTF-8. And just print out what the contents of this file is. Okay, and if I can't read that file, it's going to catch that an exception. And I'll just print out something. Looks good. All right, so let me give this a shot. So we're encompass this reading of a file in a try statement, and if there's an error, an exception, we'll catch that exception and just print out the word error followed by the text of what that exception is. And it just prints out the contents of the file, so nothing spectacular. And let's see if we try to print something that doesn't exist. So let's say it's that file. It's not, I haven't written that file. And we get that error that we just printed, and then that whole the error message. Sweet. And it's always a good idea, and we'll see it used more often later on in the course of using these tries and catches. Let's see how a throw might work. Let's say, I'm kind of faking the input here, but let's say we've invented some computer game and the only allowable keystrokes are L for left and R for right. So let's do that. So let's say, the person put in left. And here, let's make sure that the person put in a L or R. So the prompt doesn't, if the prompt doesn't equal L and the prompt doesn't equal R, we'll throw error. Okay, and let's catch that error. Just make sure we see that it's the error. All right, I think this will work. So we are trying this block, but if there's no, if the person didn't put in an L or an R, we'll get this error. And let's just say moving whatever direction we wanted to go. All right, so let's give that a shot. So moving left, because left is allowable, let's put in W here. So that should do the error. So we get my error, invalid direction. So we see how we did that, right? So we are doing a check here. If the prompt doesn't equal L or R, we're throwing an error. We're creating a new error object, and we're catching that here in this catch block. So that's the try, catch, and throw examples. Finally, the last thing I want to cover in this video is functions and how we can write different functions. There's ordinary functions, which look pretty much like any other programming language. They look like this, where the name of the function is sum here, so the thing after this word function is the name of the function. Sum ABC, so that whole blurb there, that's called the head of the function declaration. ABC are the parameters. The body of the function is everything between those braces, and the return statement returns a value. So let's see how this works. Let's just go with the sum. We just want to return the sum of those three numbers. Let's make it harder than we need to by adding a line result. And then we'll return result. We can also do assert, so let's add that in. So let me load in that assert statement. Whoops. So we think we should get 6 here. And let's just do the console log of that too. So we get the answer 6, so it's working correctly. So the benefit of this assert is we know how it should work, but we may have an error. Maybe we made a mistake here and stuck in a minus or something. And there we get that assertion error. So it's a good practice to have these asserts, just kind of reiterating and reinforcing that assert use. So that's the basic function. There are 3 basic roles of a function in JavaScript. One is that it can be invoked as a function call, as we see here in this example. The other role is that we can store it in a property of an object and invoke it via a method call. So let's see how we can do that. So we have this function sum. And then I can stick it in as a property of an object. So let me just create an object here. And just put that function there, that sum object. And let's just do that assert equal. And it's pretty much the same. We're saying that has to equal 6. And let's just print that as well. Let me just copy that. So here I'm using it as the property of an object invoked via a method call. And I better fix this before I give it a shot to make sure I get the right result. So here I'm declaring my function. And here I'm storing that function in a property of an object. And here I'm invoking that via a method call. So let's see how that works. So I get the answer 6. So that's storing a function in a property of an object. The third use of a function is as a constructor function via new. And how that works is this. And let me just make sure that it's the same thing. So is an instance. Okay, so we can try to see if that equals. We can do assert equal. So here this inst, we're using it as a constructor function. And you see it is true. So inst is an instance of sum. There's also another way of writing functions, and these are called arrow functions, and this is a syntax. So we have the name of the function, followed by an equal, followed by the parameters, with the body of the function following the arrow. So let's take a look at how those work. Let me get rid of this. So I can call that sum, just like the other one, or let's just call it arrow, just for grins. And the parameters are A, B, and C. And then we put that arrow in, and next we put the body of the function. So I can just say return A plus B plus C. And let's just print it. It prints 6, not surprising. So it works the same way as the regular function definition. So we can invoke it just as kind of a regular callable function with this arrow. You know, we give it the name and the parameters. And we construct it as I showed up above here, where we give it the name equals the parameter list and then that arrow with the body of the text. And finally, we can have things called method functions. The definition of these functions looks like this. And so let's see how that would work. Let's just delete all this here. So I'm creating an object, And within that object, I'm going to have a function, let's call it, or a method rather, the sum method. And it takes C as parameters. And the only thing I wanted to do is return A plus B plus C. All right. And how I invoke that then is I just say, use the object and the method I want to use. Okay, let's give this a shot. And it returns 6. So now we've seen different ways of writing functions. The one are most familiar with is just put that function word in front of it, and then the function name, f name, the parameter list, parameter 1, parameter 2, and so on. And then the body of the function. We've also seen the arrow function version, which is, let's just call it arrow, with the parameter list, parameter 1, parameter 2, and then followed by that arrow and followed by the body of the function. And we saw this method version of writing functions. So these two will be fairly common. This arrow method we'll be seeing, and the general function name one, the one we're most familiar with, we'll be seeing throughout this course. And let's just put this into practice with kind of a trivial, what you take in the beginner programming course that'll compute the Fibonacci numbers from 0 to 10. So just as a reminder, so f of the Fibonacci of 0 is 0, the Fibonacci of 1 is 1, and the Fibonacci of n is the Fibonacci of n minus 1 plus Fibonacci of n minus 2. So again, this should be fairly trivial. We all can write it probably in our sleep in whatever programming language we know, but just kind of a way of looking at how the pieces work together. So let's give that a shot. From 1 to 10. All right, that looks good. Just to show a multi-line column. All right, and let's write our function here. Let's write the traditional one, function fib. It takes an argument of n, whatever number we want, and here if it's smaller than 2, let's just return n. So if it's 2 or greater, return fib n minus 1 plus fib n minus 2. Let me just save this so the formatting looks a little better. There we go. Cool. All right. So let's call that from 1 to 100. So we need a little for loop. And this is turning out much easier than I thought it would be, but at least we get a little bit of practice. Whoop. All right, let's see if this works. And it looks like it does work. So the Fibonacci of 1 is 1, the Fibonacci of 2 is 1, the Fibonacci of 3 is 2, and so on. So it looks pretty good. And it's just a simple program, just kind of putting some parts together of just seeing that, hey, this, the JavaScript, the basic stuff isn't that much different than any other programming language that you're familiar with. So that's it. I'm hoping that this kind of gets you started with JavaScript. I just wanted to have a little video that introduces you to, hey, JavaScript isn't that much different from what I know, and just giving some examples that help you translate from programming languages to the JavaScript format. Next time we'll look at something that's really more JavaScript specific, that of asynchronous programming, and finally the video after that we'll start looking at, well, how can we actually use this to create a backend server? So thanks very much for watching. See you next time.